Hello and welcome to another tutorial. Today we are going to be talking about Python, very popular programming language, because there is one very confusing concept in it which is quite basic to the language itself, but it took me some time to properly understand it, so I want to help you to get through this initial hurdle, and that is about how you pass variables to functions and what happens to these variables once you pass them to functions. And this is not just important if you are programming in Python. This is very similar how it handled in other languages that are inspired by Python, such as the GD script of the Godot language. So passing parameters is a very important concept because we like to divide our program into different functions, and all these functions have their own variables and they cannot see each other's variables, so it's very important to have a mechanism where we pass information from one of these functions to another. And in many languages you can decide how you want to pass these parameters. You might want to pass them as values or as references. So a very simple example: in C++, we define this test function here, which will get one value and then we'll multiply this value by 10 and then print this value. And when we invoke this, so let's say that we first define our other variable as b, so it will assign the number 3 here to this variable b, and which will be stored somewhere in the memory. And when we assign this variable invoking this test function, what will happen is this value will be copied, and this copied value will be assigned to this a variable of our test function. And when we modify this variable by multiplying it by 10, then this 3 will be changed to 30 here, and we print this out, and when we return to our original function, this b variable will be untouched. We can do it by reference by using this ampersand symbol in C++, and what will be the difference is that once we pass this variable to our test function, invoking the test function here, what will happen is this a variable will actually just point to the exact same number or the exact same point in the memory that this b value is pointing to. And when we modify this value, it will also modify the number in our b variable. So when we exit this function, the value of this b variable will be the changed one. And so in Python, what we can do is we can try very similar thing, but in Python I wanted to use the exponential function because why not? So let's define our test function, and we will say that a equals 10 to the power of a, and then we will print a, and this is our function. And so let's get a variable called b equals 3, and in IPython, so I use IPython as my interpreter. In IPython I just give my variable name and it will just return me the value, and I can do test b here. You can see that the result will be printed, and if I check my b variable, then well, it seems like this have not changed. So it looks like when I pass a variable in Python, what happens is kind of passing by value. And so we can, of course, if we want to get this modified value, we can use the return keyword to get one variable back, but I think this is not the confusing part of things. The confusing part starts when we are moving away from simple numbers and starting to work with other things such as lists in our arguments. So let's go back to our console here. Let me just delete b and test. So let's just get rid of these, and let's clear the screen. So let's define my test function here as a equals a plus 10. So what we can do in Python is we can just use the plus symbol to concatenate lists together. So we can print this a, and if I make my b variable here list of 1, 0, 1, and 2, and I invoke the test function with this variable, you can see that this 10 got concatenated at the end. But if I go and check what's in my b variable, then you can see that it is unchanged. But if you learn Python, and you might know that for lists, we have this append property, not a property, this append function to every list that we can use to just append one object to the end, so we don't have to concatenate, we can just use the append function here. So let me change my test. So instead of a equals a plus this list with the element 10, what I can do is a dot append and 10. So let me check that my b variable is just 0, 1, 2, and now let's test b. So invoke the test function with b, and you can see that the output is the same. So we got 0, 1, 2, and 10, just like with the previous version of our test function. But if I go and check my b variable, you can see now it's changed. So have it been passed as a reference or have it been passed as a value? So it seems like neither or both. So it is very confusing. So let's take a look how Python handles this. So if we want to model it with the same kind of figure that we used for C++, so when we define our b variable as this list, then this gets stored somewhere, of course, and when we pass this to our function, what happens is that a actually will be the same as b. So it seems like it is passed as a reference at the moment. So what happens is that a and b will be the same exact list. So this did not get copied, it is the same list. But what happens is that when I invoke this line here, that a equals a, and concatenate it with this list of only one element here, what will happen is that now I assign a to something. So what will happen is this is when we break the link, and we will break the link to a equals 0, 1, 2, and 10. So now we broke the link. So once we exit this function, it doesn't matter what's going on here because our b variable have not been changed. But when we use the append function, there is no a equals something here. So we just assign a to the same thing that b is, and then once we modify this list, then it is modified in both a and b, because here we did not reassign the variable a, we modified the list itself. So in Python, what we do is we don't think about the variables themselves, but we have to think about what they represent. And so we have to be conscious that whenever we use this equal sign there, that will change what is in our variable. Then that we can use this id function to help us with this. So id function is telling us the identity of the variable. So let me just get rid of b and the test here and clear the screen. So if I make b equals this 0, 1, and 2, this list, I can check the identity of b. So this will be a long number. This identifies basically where the memory segment may be. We could think that this is where in the memory b is stored. And if I say b.append 10, you can see that the identity of this have not changed. So b is still pointing at the same place in the memory, but that part of the memory have been changed. So this have been changed. But once I do b equals b and concatenate with another list, for example, the one that contains 20, then checking the identity of b, you will result in a different number, because now that we reassign b to something else, the identity of b have changed. And of course, this is how it works with the functions. So once we reassign it and change the identity, now it's not the same thing that we were accessing before. Okay, so I have to cut this in because I forgot in my original script to talk about this, but I have to show you that if I do my new function as test a, and then I do a1, let's say 1 equals 10, and then let's print a out there, and then I have my b variable the same as we had, and then we do test b, and then we get what is in B. So you can see that this is the same as if we just used the append function. So just because we assigned something to one member or one element or one, how do you call it, like a one member, I guess, of the list, that does not change the whole list, that only changes part of the list, and A is still the same as B, as you can see here. Now back to the original video. So I hope this cleared up things a little bit. So once we understand this one, then we can go back to our numbers. And well, in numbers, how we can use this for numbers? Well, B is just 1, but once I invoke this function, A will point to the same thing, which is 1. But then when I change this, you cannot change a number. So numbers are unchangeable. 1 is always 1, so you cannot change 1. The only thing you can do is reassign A to a different number. So this is why when you just work with very simple variables like numbers, then you cannot change when you have to reassign. The same with tuples. Tuples cannot be modified. You can reassign the variable to a different tuple, but you cannot modify the tuple. Same with numbers. So this is how it works. The link does not break when we pass the variable to the function. The link between the two variables break at the point when we reassign the variable to a new value. And of course, this is also something that some people on the internet, I've seen a video where they show you this, that A equals 3 and B equals 3, or no, sorry, B equals also 3. And if I say ID A and ID B, then this is the same thing, even though, so these are numbers, same numbers, but if I say A equals 4,000 and B equals 4,000, and I say ID A and ID B, these are different numbers. So this is kind of an implementation detail of how the numbers in Python are handled themselves, but it doesn't really matter from our practical perspective, because it doesn't matter if this one is the same or not as, so it wouldn't matter if I reassign here, let's say A equals 1. Again, it would not really matter if this one is the same one as this one, or is it the same, or it's a different one. It doesn't really matter, because the numbers itself are immutable. You cannot change the number itself. You can reassign the variable to a different number, but you cannot change the number itself. And so the weirdest thing is even more weird than this. So this was weird for me, but at least, once you understand how reassigning a variable changes where it points to, then you can kind of build a good mental model and understand what you have to do in your functions. So you have to be careful that if I just use the append function, that will modify my original list too. So maybe you want to copy first before you do any modification if you don't want this modification to propagate back. So there are different methods to deal with this, but you have the mental model, so you know what you're doing. But what happens? So can you predict what happens when you do this? So we need to define a new function here. So let me clear the screen and delete B and also tests. So we don't have tests. Anyway, that's good. Let's get rid of this error message. So let's make a new test where A equals an empty list, and then we use a.append 10, and then we'll say print A. So what this function is going to do is that it's going to append the number 10 at the end of our list, and if we don't specify any list, then it will just use an empty list here. So I can say test and just add the list here, and this will be appended. And so of course now you know that if I use the B equals 0, 1, 2, and then test B, and then my B is modified. Okay, so this is all fine, but what will happen if I just say test with an empty list? And of course the list have been appended the number 10 at the end, Very nice. But what happens if I do it again? And again, and again? So what's going on here? What's going on here? So let me just open the definition of the function again. So what happens here is that this list that we define here as an empty list, it gets assigned to this function a, or that function, this variable a. And once we start modifying this a variable, this function definition itself will have this empty list there modified. So let me just press enter again. So I redefined the test function, and it seems like it also reinitialized the empty list, but I can go on like this. And if I just define another one, test2, well, let me just redefine test again, and then define test2 and also a equals empty list, and then a dot append 5 or something like that, and print a. So now I have test and test2. So if I say test, that's going to do the same thing. If I say test2, that's now doing with the numbers 5. So the thing is that this seems like in IPython, when you define these two different functions, both with the empty lists as the default value, these empty list and this empty list are actually different empty lists. So once you are doing this, just calling the function without any argument again and again, this empty list will be only modified by this command, and this empty list will only be modified by this command. But I read somewhere that different Python interpretations, or different Python implementations rather, so different interpreters might just simplify, oh, you can see there is an empty list here, there is an empty list here, so they just assign the same empty list to both, and both function will modify this. So this is kind of the weirdest thing in Python. I didn't even know about this until yesterday. And now that you understand how the parameter, how to pass parameters to functions and how that works, now you can kind of understand why is this weird behavior observed in Python. So if you ever have to do something like this, then you should rather go with another solution, like a more kind of manual solution to this problem, which I saw, like one suggestion is just use def test a equals none, and then if a is none, then make a equals the empty, and then I guess a dot append 10, and also we can print a. Will this work? Yeah, and you can see that now this works, because every time we open this function, this is reassigned. So yeah, it is reassigned and not modifying the same thing, I guess. I am not 100% sure why this works and why this works this way, but something has to do with something about this empty not being in the same position as this. And I thought yesterday I understand why this works, but now I'm just confused. So if you have any idea why this works, then tell me down there in the comments. But now you know, at least, this weird behavior. And I really thought I understood this, but here I defined this empty inside an if clause. Maybe that's the difference. I'm not sure. If I just do this, then of course, or rather I should have used a different number here. Yeah, this will work. What happens here to the variable a? What happens to this empty when it seems to me that when I append, maybe it's just maybe it's just the different behavior if you define it inside as a default value, and when you define it this way, I'm not sure. Yeah, I'm not sure why is this different. But anyways, I hope you learned something today. And, well, yeah, leave a comment down below. And give me a thumbs up if you enjoyed. Subscribe. Follow my Mastodon account. I have Mastodon. You should go on Mastodon and find me and follow me there. And share this video with people who are confused about Python. And I guess I'll see you in the next one. Bye bye.